Hello everyone. How are you all? I hope that all of you are doing amazingly great. First of all, welcome to this session. So we are on lecture number 3 of basic mathematics. In the previous lecture, what did we learn? We learned about intervals. We learned about wavy curve method. So the previous lecture was very important. Okay, I hope you understood the previous lectures. If you have any question, if you have any doubts, you can feel free to ask in the comment section. I will help you, and also many other students will also help you, because see, peer-to-peer learning is very important. It's not about just teacher to student, it's also about student to student learning. So when you ask a doubt in the comment section, what happens that if I don't answer, some other student will answer at least. Okay, and then the peer-to-peer learning will be very beneficial, right? That is why everybody wants to go to the best of the colleges. Everybody wants to go to IIT or the best international level colleges. Why? Because more than teachers, there is peer-to-peer learning. The best minds reach to the best colleges. The best minds reach to IITs or many good colleges. So basically peer-to-peer learning is really important, that you can form an ecosystem in the comment section, so that I know that yes, all of you are interested in learning, all of you are learning continuously. Okay, so this is lecture number 3 on logarithm. Let's get started with this lecture. So first of all, what is log? How do we define the log? Okay, so in the last class we learned about exponential, right? Suppose if I ask you what is 2 raised to the power 5, 2 raised to the power 5, you will say that this is equal to, everybody knows that this will be equal to 32, right? 2 raised to the power 4 is 16, 2 raised to the power 5 is 32. Okay, so basically what are the terms that you need to understand here? What is 2? 2 is the base. 2 is base over here, right? This is base, correct? What is 5? 5 is power, or we can call it exponent. So if I raise this base 2 to the power 5, right? If I raise the base 2 to the power 5, I get the number as 32. This is exponential. Logarithm, what does logarithm do? Logarithm gives us the power. It gives us the exponent. Okay, it gives us the exponent, it gives us the power. So basically if I write the same statement in the logarithmic format, this is how I am going to be writing. So here I say that 5 is equal to log of 32 to the base 2. Same statement. These two statements are what? Same statement. Here we say that log of 32 to the base 2 is equal to what? 5. What does it mean? It means that basically it means that if I raise this, what is the power that I need? Right? What is the power the base 2 has to be raised to get 32? So logarithm gives us what? Logarithm gives us power. It gives us the exponent. Log of some number to the other number will give us the power. So the basic definition, this is just a little bit of idea. Now the basic definition of logarithm goes like this. So log of a to the base b. This is how we represent, and this is how we call. Log of a to the base b gives us the power that the base b, the power that the base b has to be raised to get a. Basically if I am writing log of 32 to the base 2, this means that I am asking you the power that the base has to be raised to get this number 32. Basically I am asking you this question, that what power the base 2 has to be raised to get this number 32. So you can directly answer that yes, we know that base 2 has to be raised the power 5 to get 32. So this is the basic definition of logarithm. What is logarithm asking us? Log is asking us about power. that what power the base b has to be raised to get this number a. So if log of something to the base something is written, it means it is asking you power. Log asks you power. Log gives you power. Okay. Log also gives you the power to get selected into IIT. Okay. That's it. So log of a to the base b gives us the power that the base b has to be raised to get the number a. Mathematically, we are going to be writing like this. Okay. Let me. So mathematically, we are going to be writing it like this. See, have a look. So suppose if it is given that log of a to the base b is equal to some number c. If this statement is written, this statement is currently in its logarithmic form. This statement currently is in the logarithmic form. It is written as log of a to the base b is equal to some number c. Now, till now, everybody understand that what is this c? C is the power. Log gives us what? Power. So c is the power. Okay. Now, if I write this statement in the exponential form, see, this is the exponential form of the statement, that 2 raised to the power 5 is equal to 32. This is the exponential form of the statement, and this is the logarithmic form of the same statement. That log of 32 to the base 2 is equal to 5, the same statement. So it is very important to understand that how do we convert logarithmic form into exponential form, and it is very, very easy. Basically, just go with the definition. So the definition is saying that if log of a to the base b is equal to c, it means that we need to raise this base b, we need to raise this base b to the power c to get this number a. C is what? C is power. If I raise this b to the power c, I get the number a. So this is the logarithmic form, and if I want to convert this in the exponential form, if I convert this in the exponential form, it will be written like this, that a is equal to what? A is equal to b raised to the power c. If I raise this number b to the power c, I will get the number a. So basically, this is the logarithmic form of this statement. Okay. This is log form or logarithmic form, and this is the exponential form of the same statement. Exponential form. Like you must have studied about active voice, passive voice in English, right? We can say the same statement in active voice and the passive voice, that the Ram has done the work or the work has been done by Ram. The same statement, but we are saying in different formats. In the similar way, these two statements are the same statements. Log of a to the base b is equal to c means that a is equal to b raised to the power c. Basically, we are raising this base b to the power c to get this number a. So, active voice, passive voice. In the similar way, logarithmic form, exponential form. So, we need to understand how to convert from logarithmic to exponential and how to convert the exponential form to the logarithmic form. Okay, it is very important to understand that. So, it's very easy to convert logarithmic into exponential. Have you all seen the movie Bahubali? So, here I am giving you this Bahubali method. Bahubali method says that, okay. Basically, in the movie Bahubali, you must have seen that scene, right, where the Bahubali lifts, right, that shriveling on his shoulder, right. In the similar way, this base b is lifting this number c. So, basically, what is b? B is the Bahubali over here. B is Bahubali. Currently, B is in the base of log. Currently, B is in the base of log. So, to convert it into the exponential format, B has to become the Bahubali over here. Okay. If B becomes Bahubali, B goes to the right hand side. Okay. It crosses the river. It crosses the river, it goes to the right hand side, and it raises the right hand side on its shoulder, on its power. So, b raised to the power c, and here we have only a remaining. So A is equal to B raised to the power C. This is Bahubali method. So if you want to convert the statement, the logarithmic statement into exponential statement, just simply use this Bahubali method. Just simply send this B to the right hand side. It will become that Bahubali. It will raise this C to on its shoulder, right? So B raised to the power C is equal to A. Are we clear about that? In the similar way, if I want to convert this exponential form into logarithmic form, I need to send this B again. I am sending this Bahubali back to its home. So in its home, it will be, sitting in the base. Okay. So log of A to the base B is equal to C. So you should be very easily, able to convert logarithmic form into exponential and exponential into logarithmic. Okay. Are we clear? Now here we have some rules. Log is a function. Basically later on in functions, you will understand that what is log? Log is a function. Okay. So in this function, every function has some rules, every function has some domain and the range. You won't be able to understand these terms for now, but remember two things about log. Log of A to the base B is defined only when log of A to the base B is defined only when, okay, there are some conditions attached to it. Not every log is defined. Log of negative numbers are not defined. Okay, so not every log is defined. So it is defined only when there are conditions. The conditions are only when A greater than 0. This number A should be a positive number. Only log of positive number is defined. Log of negative number is not defined. Log of negative number is not defined. So this A should be positive. This base B should also be positive. B should be greater than 0. And this B should not be equal to 1. These are the conditions associated with log. These are the conditions. Okay. Important conditions. Every log comes with a condition. These are the conditions. That this number A should be positive, this B should be positive, and this B should not be equal to 1. The base should not be equal to 1. These are the conditions. Okay. There are reasons behind it, why A should be greater than 0, why B should be greater than 0. Of course, there are reasons behind it. Okay. Let me just, first of all, you need to remember these. Take a condition. Okay. Then I will just give you a hint that why it happens, why A should be greater than 0, why B should be greater than 0, why B should not be equal to 1. Suppose if I ask you what is the, let's talk about why. Okay, don't go too much into these why. Okay, I'm just giving you an idea why, but you don't need to, go deep into this. Why, sir? Why not this? Why not that? You don't need to go into that for now. When you will study function, you will have a better understanding that why does it happen. But it will come when you will study function, when you will be studying about the graph of logarithm, then you will be able to understand why this happens. But I'm just giving you a little bit of idea. Suppose if I ask you what is log of -32 to the base 2. Okay. What is log of -32 to the base 2? So you can't say that this is equal to -5. No, of course not. Suppose if you say that this is equal to some number x, let's say. So basically what is this x? X is the number. When you raise this 2 to the power x, you are getting number -32. Is it possible? So basically -32 is equal to what? 2 raised to the power x. This is logarithmic form. I have converted it in the exponential form. Okay, this is the first step I've done. I've converted it in the exponential form. Now there is no value of x. There is no value of x for which 2 raised to the power x is equal to -32. There isn't any value of x available. Even if you take x as -5, then also it is not possible, right? Are you able to understand that -5 is not satisfying this equation? Because 2 raised to the power -5 is 1 upon 32. 2 raised to the power -5 is 1 upon 2 raised to the power 5, right? Basically that is 1 upon 32. So again, this is not working. There isn't any value of x. So log of negative number, we are not getting any number. So log of negative number is not defined. Log of negative number is not defined. So a should be greater than 0. In the similar way, this base should be greater than 0. Okay. Like suppose if I ask you what is log of 32 to the base minus 2, it will not be defined. How will you say that what is the, you are not getting any exponent over here. It is not equal to 5, it is not equal to minus 5, it is not any number, it is not even defined. That's the thing. Okay. Base should not be equal to 1. See, if base is equal to 1, suppose if I ask you what is log of 32 to the base 1, I'm just taking number 32, you can take any other number as well. You can take, let's say 5. Log of 5 to the base 1. Okay. Now, can you tell me what's the value? So suppose if you take this value equal to x also, then if you convert this into the exponential form, 5 is equal to 1 raised to the power x. What power of 1 is equal to 5? There isn't any power of 1 that is equal to 5. 1 raised to the power 1 is 1, 1 raised to the power 2 is 1, 1 raised to the power 3 is 1, 1 raised to the power 4 is 1. So I hope you understand the reasons that this is why, okay, log of negative number is not, a should be greater than 0, b should be greater than 0, and b should not be equal to 1. The base should not be equal to 1. This number a can be equal to 1. That works. That isn't any problem. A can be equal to 1. Log of 1 is defined. Okay. So there are some important properties that if I ask you what is the value for log of 1 to some base a, let's say. So what is the value for log of 1? The value for log of 1 to the base a, if I want to find this value, how do I do that? Just consider, okay, consider log of 1 to the base a is equal to some number x. We don't know the value, we want to find the value of x. Let's say that log of 1 to the base a is equal to x. So basically, if I convert this into the exponential form, this base a goes to the right hand side and acts as a Bahubali, right? Base is Bahubali, right? So a goes to the right hand side, a will raise this x to its power. So 1 is equal to what? 1 is equal to a raised to the power x. Now what power of a is equal to 1? We know that a raised to the power 0 is equal to 1, right? All of you know that? That a raised to the power 0 is what? 1. Where a should not be equal to 0, of course. So a raised to the power 0 is equal to 1. So this power has to be what? 0. Or you can directly answer also. You can directly answer. Basically, what is log giving us? Log is giving us the power. What power this base a should be raised to get this number 1? So we know that if I raise this base a to the power 0, a raised to the power 0 is equal to 1. Okay. So log of 1 to the base a is equal to 0. This is the first property. The second property, if I ask you what is log of a to the same base a, log of a to the same base a, that should be equal to what? 1. Because a raised to the power 1 is equal to a. A raised to the power 1 is equal to a. So log of a to the base a is equal to 1. So here what is a? Condition is attached that a should be greater than 0, a should not be equal to 1. Because a is in the base as well. It is in the base. So base has some responsibility. Okay. So log comes with the condition. There is a condition on this number, there is a condition on the base. What's the condition on the base? That base should be positive. This number should also be positive. Basically, both of them should be positive. But there is an additional condition attached with the base that the base should not be equal to 1. Okay. Now let's practice some examples on it. See. Log of 8 to the base 2. If somebody asks you what's the value for log of 8 to the base 2. So basically they are just asking you the power. The power that the base 2 should be raised to get this number 8. What power the base 2 should be raised to get the number 8? So we know that 2 raised to the power what? 3 is 8. 2 raised to the power 3 is 8. So what will be our answer? Our answer will be 3. Either you can directly answer like this. Okay, this works if you can directly see that yes, 2 raised to the power 3 is equal to 8. Or what you can do, you can convert it in the exponential format. Suppose if you don't know, the value of log of 8 to the base 2. Okay, suppose if you are not able to get the value, simply consider this value is equal to x. Now send this base 2 to the right hand side, so we get 8 is equal to 2 raised to the power x. So what will be this value of x? X will be 3, because we know that 2 raised to the power 3 is 8. Simple. Okay, so this is the logarithmic form of statement. If I convert this statement in the exponential form, it will be like this: 8 is equal to 2 raised to the power 3. This base 2 goes to the right hand side, raise it 2 on its power. 8 is equal to 2 raised to the power 3. So basically both of these statements are the same statement. This is the logarithmic statement, this is the exponential statement. Now what will be the answer for the second part? Okay, many students do this mistake that they give the answer as equal to 10. Are you getting the answer as 10? Yeah? No, 10 should not be the answer. 10 raised to the power 10 is not equal to 100. 10 raised to the power 2 is equal to 100. You get it? 10 raised to the power 2 is equal to 100. The base 10 should be raised to the power 2 to get this number 100. Or we can convert it in the exponential format like this, that 100 is equal to 10 raised to the power 2. This 10 goes to the right hand side. We have 100 in the left. 10 raised to the power 2 is equal to 100. We know that. Okay. Log of root of 2 to the base 2. This is the next example. Log of root 2 to the base 2. Now all of you understand that root 2 is what? Root 2 means 2 raised to the power 1 by 2. Everybody gets this? Yeah. So what power should we raise the base to get 2 raised to the power 1 by 2? So base is 2. We need to raise base 2 to the power 1 by 2 to get root 2. So here simply the answer is 1 by 2. Log of root 2 to the base 2 is equal to what? 1 by 2. Simple. Log of 1 by 16 to the base 2. Fourth example. Have a look at the fourth example. Log of 1 by 16 to the base 2. So what power the base 2 should we raise to get 1 by 16? We know that 2 raised to the power 4 is 16. And what will be 2 raised to the power minus 4? 2 raised to the power minus 4 will be 1 by 16. So we need to raise it to the power minus 4. 2 raised to the power minus 4 will be equal to 1 by 16. So the value of log can be negative. There can't be negative number inside the log, but the value of log can be negative. Like suppose if I ask you what is the value for log of 1 by 5 to the base 5. So how will you answer this? What power should we raise this base to get 1 by 5? We know that 5 raised to the power minus 1 is 1 by 5. Power can be negative. Right? Power can be negative. We know that 5 raised to the power minus 1 is 1 by 5. So our answer will be minus 1. So the value of log can be negative. The value of log can be negative, but we can't allow negative number inside the log. This number and the base should be positive, and the base should not be equal to 1. These are the conditions attached with logarithm. Okay. Now, log of 16 to the base 1 by 4. So 1 by 4 raised to the power minus 2 will be 16. 1 by 4 raised to the power minus 2 will be 16. If you convert it into the exponential format, it is clearly visible that 16 is equal to what? 16 is equal to 1 by 4 raised to the power minus 2. This is the exponential format. That if I send this 1 by 4 to the right hand side, 1 by 4 raised to the power minus 2 will be equal to 16. Correct? So either you can directly answer, and if it happens that you are not able to directly answer, suppose in this case you are not able to directly answer, or suppose if I take a better example, let's say log of 64 to the base 1 upon 2 root 2. Okay. Now if I asking you this question, what's the value for log of 64 to the base 1 upon 2 root 2? Now it is not as simple as that. Now it is not as direct. That what will be our answer? I am not able to directly answer. If it happens that you are not able to directly answer, then what you can do, you can just simply consider this number is equal to x. Okay, let's say that this is equal to x. Now I need to find x, convert it into the exponential format. Okay, because we are more comfortable with the exponential format, so simply convert it into the exponential format. We can write that 64 is equal to 1 upon 2 root 2. That is the base to the power x. Base goes to the right, acts as a Bahubali, right? 1 upon 2 root 2 will raise this x on its power. So 1 upon 2 root 2 to the power x is equal to what? 64. Now solve it, solve this equation. How do you solve this equation? You can write 64 in the power of 2. That 64 is what? 2 raised to the power 3 is 8. 8 into 8 is 64. So basically 64 is what? 2 raised to the power 6. So you can write left hand side, right, as 2 raised to the power 6. In the similar way, 2 root 2 is what? Root 2 is 1 by 2, right? 2 raised to the power 1 by 2. So you can write 2 root 2 as 2 raised to the power 3 by 2. Do you get it? 2 root 2 is nothing but 2 raised to the power 3 by 2. How the power 3 by 2? See, here we have 2 raised to the power 1. See, this is basically what? 2 raised to the power 1 multiplied by 2 raised to the power 1 by 2, right? This is this. 2 raised to the power 1 multiplied by 2 raised to the power 1 by 2. We add the powers if the base is same. Base is same, we add the powers. So basically there are some rules associated with exponential, that if we multiply two numbers, their bases are same, we add the powers. In the similar way, you are later on going to see some rules with logarithm. Okay, so we are just following the rules of exponential over here, that we can write 1 upon 2 root 2 as 1 upon 2 root 2 as 1 upon 2 raised to the power 3 by 2. Its whole power x. 1 upon 2 raised to the power 3 by 2 can be written as 2 raised to the power minus 3 by 2. It can be written as 2 raised to the power minus 3 by 2. Its whole power x. Basically, I am writing 1 upon 2 raised to the power 3 by 2 as 2 raised to the power minus 3 by 2, and we have its whole power as x. So now the powers will get multiplied. Minus 3 by 2 multiplied by x, you know the property. So now the right hand side is what? Now the right hand side is 2 raised to the power minus 3x by 2. This is right hand side. The left hand side is 2 raised to the power 6. Now the base is same. Base is same. We just need to equate the powers. Right? Bases become same. Now what do we need to do? Simply equate the powers. The power over here is 6. The power here over here is minus 3x by 2. So it implies that 6 is equal to minus 3x by 2. Okay. Equate the powers. Now what is the value for x now? The value for x will be equal to C2, this 3 to the 6. So x will be equal to minus 4. X is equal to minus 4. That's our answer. That's the value for log of 64 to the base 1 upon 2 root 2. Its value is minus 4. Basically it means that if I raise this base 1 upon 2 root 2, if I raise it to the power minus 4, if I raise it to the power minus 4, I will get which number? I will get 64. Correct? As simple as that. Now let's move ahead. So I hope you have understood how to find the values of log. Now this question, which of the following are incorrect? Like what is the value for log of under root of 8 to the base 2? It is given equal to 3 by 2. Is it correct or not? Okay. We are looking for the false statement. We are looking, so basically one of the statement is false. One of the statement is false. Okay, we are looking for that. Okay, now, so you can simply convert it into the exponential format, that 2 raised to the power 3 by 2. Basically this statement is saying that under root of 8 is equal to what? 2 raised to the power 3 by 2. Is this true? You tell me, is this true? Under root of 8 is equal to 2 raised to the power 3 by 2. It is true. Yes, it is true. Why it is true? Because what is under root 8? What is 8? 8 is 2 cube. 8 is 2 cube. So under root of 2 cube. Under root means power 1 by 2. So basically this is 2 cube raised to the power 1 by 2. I am going from the basics. Okay, so 2 cube raised to the power 1 by 2, basically this is 2 raised to the power 3 by 2 only. Okay, so yes, this statement is correct. So we are not selecting this. We are looking for the false statement. Now the second statement will be wrong then. Second statement will be wrong because log of under root of 8 to the base 2 will not be equal to 3 by 4. We have already seen that this is equal to 3 by 2. So second statement is wrong. The third statement is also wrong. Okay, so simple question, not a big deal. Now let's move ahead. So log of a to the base a is equal to what? 1. These are some of the statements you need to remember about logarithm. That log of a to the same base a is equal to 1. Suppose if I ask you log of 2 to the same base 2, that will be equal to 1. Suppose if I ask you log of 5 to the same base 5, that is equal to 1. Suppose if I ask you log of pi to the same base pi, that will be equal to 1. Log of negative numbers are not defined. That's the thing. You can't write log of minus 2 to the base minus 2 as equal to 1. Basically, this is not even defined. Okay, log of negative number is not even defined. Okay, so log of a to the base a is 1, where a should be greater than 0. A should be positive and a should not be equal to 1 because a is in the base. It is also in the base, so it should not be equal to 1. Log of 1 to the any number a is equal to 0, where this a should be again, because a is in the base, a should be greater than 0, a should not be equal to 1. These are the conditions associated with it. Logs comes with the condition that a should be greater than 0, a should not be equal to 1. Why it should not be equal to 1? Because it is in the base. Any number inside the log has to be positive, but base has one more condition, that base can't be equal to 1. Here a is in the base, it can't be equal to 1. Okay, so log of 1 to the base a is 0. Suppose if I ask you what is log of 32, log of 1 to the base 32. Suppose if I ask you what are log of 1 to the base 5, log of 1 to the base pi, all of their values is 0. Base should be a positive number and base should not be equal to 1. That's the condition. Here I can't write a negative number because then it will not be even defined. Okay, like log of 1 to some negative number is not even defined. Log of 1 to the base 1 is not even defined. Okay, these things are not defined. Log of 1 to the base 1 not defined. We can't define it. Remember this, because base can't be equal to 1. So the condition is base can't be equal to 1 and number should be positive, whether it is in the base or it is in the log. Basically every number inside the log has to be positive. Okay, the outcome of log can be negative, like log of 2 to the base 1 by 2 is minus 1. Suppose if I ask you what is log of a to the base 1 by a. Okay, log of a to the base 1 by a, this will be equal to what? Where a should be, conditions are a should be positive and a should not be equal to 1, because if a becomes 1, this base becomes 1. Okay, so that will not be allowed. So log of a to the base 1 by a is equal to what? Minus 1. Because if I raise this base 1 by a to the power minus 1, then I will get a. In the similar way, if I ask you log of 1 by a to the base a, that is also equal to what? Minus 1. Basically log of 2 to the base 1 by 2 is equal to minus 1. Log of 1 by 2 to the base 2, that is also equal to minus 1. Log of 3 to the base 1 by 3 equal to minus 1. Log of 1 by 3 to the base 3 is equal to minus 1. Yeah, it is giving us the power. Now, if positive numbers a and b both lies on the same side of 1 on the number line, then the value of log is positive. Basically it is saying that a and b, okay, listen to me, the third statement is very, very important. So listen to me carefully. Basically, if both the numbers are greater than 1, same side of unity means that either both of them are greater than 1 or both of them are less than 1. Then the value of log will be positive. Okay. Now listen to the statement 4. Basically third statement and fourth statement are similar statement. So statement 4 is saying that if positive numbers a and b lie on different sides of 1, then the value of log is less than 0. The value of log becomes negative when one of the number is greater than 1 but other number is less than 1. Of course, both the number has to be positive. Okay, if one of the number is greater than 1, one of the number is less than 1, then the value of log will be negative. Like suppose if I ask log of 5 to the base 1 by 5 or log of 5 to the base 1 by 25, we are going to get a negative number for sure. Okay, we are going to get a negative number for sure, because see, this number is greater than 1, this number is less than 1. So basically, if these two numbers are on opposite side of unity, unity means 1. If these two numbers are on the opposite side of unity, then the value of log is negative. If these numbers are on the same side of unity, basically if both of them are less than 1 or both of them are greater than 1, then the value of log is positive. So value of log will be negative if they are on opposite side of unity. Otherwise, value of log will be positive. Clear? Like if I find the value for log of 5 to the base 1 by 25, can you tell me the value? Think about the value for this number. What will be the value? Either you can directly write that the value will be what? Minus 1 by 2. Are we right? 1 by 25. If I raise it to the power minus 1 by 2, then I will get 5. If you are not able to directly find its value, not a problem at all. Just simply consider it equal to x. Then convert it into the exponential format. That this 1 by 25 in the base will become Bahubali. Right? So we have 5 in the left hand side now. So 5 is equal to 1 by 25 raised to the power x. This 1 by 25 goes to the right, becomes that Bahubali. 5 is equal to 1 by 25 raised to the power x. Okay, now, so 1 by 25 raised to the power x is equal to what? 1 by 25 means 1 upon 5 square. Okay, we can convert it into the exponential format. That 5 is equal to 1 upon 5 square whole raised to the power x. 1 upon 5 square can be written as 5 raised to the power minus 2. 1 upon 5 square can be written like this. Now the powers will get multiplied. So 5 is equal to 5 raised to the power minus 2x. Simply now equate the powers. Here we have 5 raised to the power 1 in the left hand side. In the right hand side we have 5 raised to the power minus 2x. So if you equate the power, 1 is equal to minus 2x. 1 is equal to minus 2x. It means x is equal to minus 1 by 2. So you can directly get the answer that its answer will be minus 1 by 2. This is example 1. Okay. So if the base and the number are on the opposite side of unity, then we will get a negative number. But if they are on the same side of unity, like suppose if I ask you what is log of 1 by 25 to the base 1 by 5, can you tell me the answer for this question directly? What power should I raise this base to get 1 by 25? So I directly know that if I raise this power 1 by 5 to 2, 1 by 5 raised to the power 2 will be equal to 1 by 25. Okay, directly you can answer. So see, both of these number are less than 1. Can you observe it? Both of these number are less than 1. So we are getting a positive number. If the numbers are on opposite side of unity, then we get a negative value of log. Otherwise, we are going to get a positive value of log. This is the examples basically. Okay. Are we clear? Let's move ahead. Okay, here we go. Log of 216 to the base x is equal to 3. Now they are asking us about the base. They have given us the statement, they are asking us about the base. So you can simply convert it into the exponential format, that 216 is equal to, if you send this base to the right, x raised to the power, the right hand side will be on the power now. So 216 is equal to x cube, whose cube is equal to 216. So we know that 6 cube, the cube of 6 is equal to 216. So the value of x will be equal to 6. Okay, as simple as that. Now let's get to the properties of log. Till now you have understood about log. Till now you have understood that log gives us the power. Basically log of something to the base something will give us some power basically, right? Okay. And you have understood the condition attached with log. These are the two things you have understood. Basically what does log gives? Okay. What is the logarithmic form? What is the exponential form? What is Bahubali method? Bahubali method is just simply converting logarithmic form into the exponential form, that you have understood till now, right? Other than that, second important thing is the conditions that is attached with logarithm. That you have understood that whether log of x to the base y or a to the base b, whatever is written, we need to make sure that these two number has to be positive number and the base should not be equal to 1. This base should not be equal to 1. Okay? This number x can be equal to 1. And we know that log of 1 is equal to 0. If this x is equal to 1, then the value for this log is equal to what? 0. But this 1 is not allowed in the base. Okay? So these are some important things you have learned till now. Okay, now let's study about the properties of logarithm. Basically these are laws of logarithm. There are some laws attached to exponential you have seen. You have seen that in exponential, if I multiply 2 raised to the power 5 to 2 raised to the power 7, what happens? There is a rule, there is a law associated with it. What is the rule? That if base is same, we add the powers. We add the powers, we can write this as 2 raised to the power 5 plus 7. So these are the rules associated with exponential. There are rules associated with logarithm as well. So we are going to be learning about those rules. So the first rule says that if we add two logs, like log of m to the base a plus log of n to the base a, that will be equal to log of mn to the base a. Okay. So basically it happens only when the base is same. Okay. When the base is same, base has to be same. So if we add two log, we can add two logs. Okay, we can apply this property if the base is same. So log of m to the base a plus log of n to the base a is equal to log of m into n to the base a. If there is a subtraction sign between them, that log of m to the base a minus log of n to the base a, that will be equal to log of m upon n to the base a. This time these two numbers are getting divided. Here these two numbers are getting multiplied. Okay. Basically it is the similar kind of rule. Log gives us what? Power. So basically the first statement is saying that if we multiply two numbers, suppose there are two numbers m and n. If we multiply these two numbers, okay, and they are on the same base, then basically we can simply add the powers. That's what it is saying. Let me give you an example, and suppose I write log of 8 to the base 2 plus log of 4 to the base 2. See, here base has to be same. Okay, this is the first example on the first rule, that log of 8 to the base 2 plus log of 4 to the base 2 can be written as log of 32 to the base 2. These two are the same. Left hand side, right hand side are the same. You can also observe it, that what is the value for log of 32 to the base 2? Its value will be 5. Correct? Its value is equal to what? 5. 2 raised to the power 5 is equal to 32. What is the value for this thing? Its value will be 3. And what is the value for this thing? Its value will be 2. Because 2 raised to the power 3 is 8. 2 raised to the power 2 is 4. So we have 3 plus 2 is equal to 5. Yes, this statement is correct. So it happens only when the base is same. Then only we can multiply the numbers. Otherwise we can't do that. Okay, otherwise we can't do that. Yes, of course, there's a proof behind each of these properties. We are not going to go into the proof, otherwise this lecture will go very long. We don't want that. We want to keep this session crisp and clear, so that you understand the property, you understand how to apply the property, where to apply the property. We will be more focused upon the question. So I'm not going into the proof. I'm not going to bore you with the proofs of this, but if you are interested, you can definitely check out the proof. But right now I am not going to bore you with the proof of this. Okay. Second, log of m to the base a minus log of n to the base a is equal to log of m by n to the base a. Basically, if there's a minus sign between them, let's apply minus sign between them. Example 2. Let's say log of 8 to the base 2 minus log of 4 to the base 2. What will be this equal to? We can apply this property only when the base is same. You can see that here the base is a, here the base is also a. Okay, then what happens? We divide these two numbers, log of m by n to the same number a. So in the similar way, this should be equal to log of 8 by 4 to the same base 2. Log of 8 by 4 to the same base 2. What is 8 by 4? 8 by 4 is 2 only. Yeah, so basically this is equal to log of 2 to the base 2. And what is log of 2 to the base 2? That will be equal to 1. Is it true? Yes, of course it is true. We know that log of 8 to the base 2 is equal to 3. And we know its value is 2. So we know that 3 minus 2 equal to what? 1. Okay. Now let's have a look at the example 3. The property 3. Property 3 says that if there's a number, if there's a power on this number, log of m raised to the power n to the base a, then we can simply send this power n in the multiplication. We can write this as n times log of m to the base a. Okay, I'm giving you an example on this. This example will make it very, very clear. Okay. Example 3. So suppose it is written that log of 2 raised to the power 5 to the base 2. Basically, log of 2 raised to the power 5 to the base 2. So this property says that you can send this power 5 in the multiplication. This is the property. You can send this power 5 in the multiplication. You can write this as 5 times log of 2 to the base 2. You can write it like this. 5 times log of 2 to the base 2. The value for log of 2 to the base 2 is what? 1. So 5 times 1 will be equal to what? 5 only. Okay. 5 times 1, that will be equal to 5. So this will be the value for log of 2 raised to the power 5 to the base 2. Basically this is what? This is log of 32 to the base 2, and we know that the value for log 32 to the base 2 will be equal to what? That will be equal to 5 only. So these are the 3 properties. One more property. Okay. For now, then I will tell you more properties. Property 4. So property 4 is very similar to property 3. Property 4 says that if there is suppose log of a to the base b, okay, there is some number n on the power of this, there is some number m on the power of base. Okay. So we have already studied about the property 3 that this number n directly goes into the multiplication. We have already seen that. Okay, this number n will directly go into the multiplication. What about this power which is on the base? So the power on the base goes as reciprocal over here. That's the property. Power on the base goes as reciprocal. So we can write the same thing like this, that n upon m log of a to the base b. See, the power on this number goes in the multiplication, the power on the base goes in the multiplication, but as a reciprocal. See, m becomes 1 by m, m becomes 1 by m. So n by m times log of a to the base b. Suppose if I ask you this question for an example. Suppose if I ask you what is log of 32 to the base 64. You can easily solve it one of the way. First of all, solve it by your own way. How will you solve this number? You will simply consider it equal to x. Okay. You will send this 64 to the right hand side. You will keep this 32 in the left, and you will write this as 64 raised to the power x. Apply the Bahubali method basically. 64 raised to the power x is equal to 32. Now you can write 32 as 2 raised to the power 5. You can write 64 as 2 raised to the power 6. Okay, 32 2 raised to the power 5, 64 2 raised to the power 6. So what is the power in the left hand side? 5. What is the power in the right hand side? 6x. Right? Here the power is 5, here the power is 6x. So 5 is equal to 6x. So x will be equal to 5 by 6. Correct? This will be the value for x. Or you can do this entire question like this. Simply you can do it like this, that log of 32. Basically properties makes it easy. Property is not making anything complicated. Properties is making solving part very, very easy. Like you know that 32 is what? 32 is 2 raised to the power 5. Okay. You know what is 64? 64 is 2 raised to the power 6. So directly write this. Now we know this property that this 5 will go in the multiplication, but 6 will go as a reciprocal. Okay. Are you getting the same answer? That 5 will go in the multiplication. So 5 and 6 will go as a reciprocal. 6 will become 1 by 6. So this is 5 by 6 times now log of 2 to the base 2. We have sent the powers outside. And what's the value for log of 2 to the base 2? That is 1. Okay. Log of a to the base a is 1. So its value is 1. So this answer is equal to 5 by 6 only. So this property makes it very, very easy. Okay. Property makes things easy for you. So this is the property you need to remember for now. I will be telling you about one more property, the base changing theorem, that will come upon later. But first of all, let's practice some question. Find the value for these expression. I hope you try all of these questions once by yourself. Okay, try this once, everyone. Log is very interesting. You need some practice to get command over log, definitely. But it's very, very interesting. Try both of these questions. Yeah. So basically till now, just understand what is log, what are the conditions associated with log, what are the 4 properties I have told you. So I haven't taught you much till now, but these are the things you need to remember for now. Of course, you need more practice on log to get better understanding about log. So let's solve this question. Log of 20 to the base 10 minus log 2 to the base 10. So first of all, I know many of you have reached to the answer, but let me again go with the concept. Base has to be same. Is the base same? Yes, the base is same. Base is 10. Then we can apply the property. Now the property is working. Which property? Okay. What will happen over here? Because there is a minus sign between them, these numbers will get divided. This will be equal to log of what? 20 upon 2. Okay. Log of a minus log of b is equal to log of a upon b. Okay, so it will be 20 upon 2 to the same base 10. Log of 20 upon 2 to the same base what? 10. What is 20 upon 2? 20 upon 2 is 10 only. So this is log of 10 to the same base 10. What's the value for log of 10 to the same base 10? That will be 1. So this is our answer for the first part. Now let's do the second part. See, here we have log of 4 by 7, log of 33 by 18, log of 22 by 21. But the base is not mentioned. But the base is not mentioned, right? So what's the base? If they don't mention the base, so you can consider the base as 10 for now. Basically, if you come into calculus, we consider the base as e, if the base is not mentioned. So for now, you can consider base as 10 if the base is not mentioned. Okay? So don't worry about the base if it is not mentioned. Basically, it is clear that base is same for all the 3 logs. So we can apply the property. So the property goes like this. So we are adding these two logs. So if we are adding these two logs, see, very simple example, that log of A plus log of B minus log of C will be equal to what? Because their bases are same. What are the bases? If the base is not mentioned, either you can consider the base as 10. Later on in calculus, you will see that when the base is not mentioned, we consider the base as E. Otherwise, they mention in the question. They mention in the question that log of A is basically log of A to the base 10. They mention in the question. Okay, this happens generally. So you can consider the base as 10 also over here. Okay, so basically the base is same. So because we are adding these two logs, these two numbers will get multiplied, and because there is a subtraction, this C will come into the division. So we can write this as log of AB upon C. We can write this as log of A into B upon C. So in the similar way, we can solve this one as well. That log of 4 by 7, log of 33 by 18. These two numbers will get multiplied and this number will come into the division. Okay. So we have now log of 4 by 7 multiplied by 33 by 18 and whole divided by 22 by 21. Whole divided by 22 by 21. This will be our answer. Log of 4 by 7 multiplied by 33 by 18 whole divided by 22 by 21. So we can further write this as log of 4 by 7 multiplied by 33 by 18 multiplied by this 22 by 21 can be written as 21 by 22. Right? 1 upon 22 by 21 is basically 21 by 22. Now let's solve this. Okay, so here we have 7 3s are 21, 11 2s are 22, 11 3s are 33, okay, 3 6s are 18. So we have 6 into 2, 12. In the numerator also 4 into 3, 12. So 12 and 12 gets cancelled out. Now this is coming out to be log of 1. Okay, everything is getting cancelled out. We are getting log of 1 to some base. The base can be 10 or base can be E. Basically log of 1 is equal to what? Log of 1 is equal to 0. That's our answer for this question. We are getting the answer as log of 1, which is 0. Now the next question. 3 times log of 2 to the base 10. So here we are not able to add currently because there is 3 times log. There is 2 times this log and then we have log of 5 to the base 10. All the logs have the same base. So first of all, I am sending this number 3 to the power. Because we know the property that log of m raised to the power n to some base a, this n gets into the multiplication. It can be written as n times log of m to the base a. So we know how to go from here to here. We can also go from here to here. That suppose if there is a number n in the multiplication, I can send it to the power. I can write it as log of m raised to the power n to the base a. So in the similar way, I am sending this 3 to the power of 2. So I can write this as log of 2 raised to the power 3 to the base 10. In the similar way, I am sending this 2 to the power of 3. So this is plus log of 3 raised to the power 2 to the base 10. Plus we have log of 5 to the base 10. So what is 2 raised to the power 3? 2 raised to the power 3 is 8. So we have log of 8 to the base 10 plus log of 3 square. 3 square means 9 plus log of 5 to the base 10. So now see, bases are same. What is log of 8 to the base 10 plus log of 9 to the base 10? That will be log of 8 multiplied by 9 to the base 10. Then you will be adding this also. So 8 multiplied by 9 multiplied by 5 to the base 10. So simply you can write this log of 8 multiplied by 9 multiplied by 5 to the base 10. Okay, 8 multiplied by 9 multiplied by 5 to the base 10. Because there is positive sign, we are adding the logs. Suppose if there is a subtraction sign over here, then what will happen? 8 multiplied by 9 but divided by 5. Suppose there is a subtraction sign over here, then 8 divided by 9 divided by 5. Okay, so 8 upon 5 into 9, basically that will happen, but there is a positive sign, so we are simply adding the logs, we'll get this answer. Okay, 5 8s are 40, 40 into 9, 360. So this will be log of 360 to the base 10. This is option C. Are we clear? We can't find the value for log of 360. Okay, we need to see the logarithmic table to get the value for log of 360 to the base 10. Directly we can't find, because if it is in the this, we can't express 360 as the power of 10. Suppose if there is 100, we can find. If there is 1000, we can find. If there is basically in the power of 10, if it is there, we can find. But 360, we are not able to express the in the power, right? Clear? So simply leave the answer over here. That's it. Now, find the value for this. There is log inside another log. Have a look at this question. First of all, this inside log of 3 to the base 9. Can you find its value? The value for log of 9 to the base 3 will be equal to what? Its value will be equal to 2. Do you get it? Yeah. Because 9 is square of 3. So this becomes log of 9 to the base 3. Its value is 2. So this becomes log of 2 to the base 2. The value for log of 2 to the base 2 is 1. Okay. Now, let's solve some logarithmic equation. There's an equation given in front of you. 2 plus log of 8 to the base 2 is equal to this. So we can find the value for log of 8 to the base 2. We know that its value will be 3. So in the left hand side, what do we have? In the A part, we have 2 plus 3 is equal to log of 3x plus 5 to the base 2. Okay. The value for log 8 to the base 2 is what? 3. So we have 2 plus 3 is equal to this thing. So 2 plus 3 is what? 5. Okay. Log of 3x plus 5 to the base 2 is equal to 5. Now convert it into the exponential format. Basically this base 2 goes over here, acts as Bahubali. It will raise this power, this 5 to its power. So it will be 2 raised to the power 5. 2 raised to the power 5 is equal to 3x plus 5. Now what is 2 raised to the power 5? 2 raised to the power 5 is 32. So we have now 32 is equal to 3x plus 5. 32 is equal to 3x plus 5. So what's the value for 3x now? 32 minus 5, which will be, which will be 27. So 3x is equal to 27. So x will be equal to 9. That's our answer for this question. Very easy. Okay. Now see, whatever the answer comes now, we always need to check whether that answer satisfies this equation. Basically x is equal to 9 is not a problem. We are not making any negative number. So whenever you solve logarithmic equation, this is a very important point, you can write it down. Whenever you solve logarithmic equation, check the answer. Whatever answer you get, just check it again in the equation. Okay. Why do we need to check it? Just to make sure that there isn't any negative number inside log. We are not forming any negative number inside log, just to make sure. Let me explain that through example B. So here we have same basis. So we can multiply these numbers. Log of x plus 1 to the base 3, log of x plus 3 to the base 3. Because the basis is same, we can multiply these numbers. We can write this log of x plus 1 multiplied by x plus 3 to the whole base 3. We can write it like this. Okay. Now we can apply Bahubali method. Log of something to the base something is equal to this. So if you raise, if you send this 3 to the right hand side, so we get 3 raised to the power 1, that is 3 in the right hand side. Left hand side we have x plus 1 into x plus 3. So x plus 1 multiplied by x plus 3 is equal to 3 raised to the power 1. Yeah. What is the value for x plus 1 into x plus 3? That will be x square plus 4x plus 3 is equal to 3. Okay. Now 3 will get cancelled out on both sides. So we have x square plus 4x is equal to 0. We have x square plus 4x is equal to 0. So what are the values of x we are getting from here? So there are two factors. If you take x common, it is x times x plus 4 is equal to 0, right? There are two factors. Basically, x can be equal to 0 or x plus 4 can be equal to 0. There are two values of x we are getting. Guys, this is a quadratic equation. We will get two values of x. Either you can apply Dharacharya formula, or you can just simply make factors and observe the roots. That roots are x is equal to 0. X is equal to 0. If x becomes 0, this entire thing will become 0. 0 equal to 0. Or x is equal to minus 4. Because if you put x is equal to minus 4, this thing becomes 0 and this entire thing becomes 0. So these are the two roots. These are the two values of x we are getting from here, 0 or minus 4. Now let's check it again. Can I put x as 0 over here? Can I put x as 0 over here? Yeah, not a problem. Because if I put x as 0, we are getting log of 1 to the base 3. That is not a problem. If I put x as 0, we get log of 3 to the base 3. That is defined. Log 3 to the base 3 is defined. But if I put minus 4 over here, that will create some problem. What problem is it creating? If I put x as minus 4, now we have log of what? This number will become minus 3. Log minus 3 to the base 3. That is not allowed. So whenever you get the answer, just check the answer again. So we know that we can't put x as minus 4 in this equation, right? We can't put x as minus 4 in this equation. Otherwise, there will be problem. So we are rejecting. Reject this answer. Reject. We are rejecting this answer. Okay. So the only answer is, it implies our answer is that x barabar 0 is the only answer. That's it. We are rejecting x is equal to minus 4. Okay. Now, log 16 to the base 2 plus log of 1 by 4 to the base 2, we want to find its value. Okay. Now, we know either we can directly apply the property because the bases are same. So we can multiply these two numbers, 16 and 1 by 4. We can multiply these two numbers. We can write this as log of 16 multiplied by 1 by 4 to the base 2. Okay. Because there is a plus. So we will multiply these two numbers. So log of 16 multiplied by 1 by 4 to the base 2, which is equal to log of 4 to the base 2. Log of 4 to the base 2 will be equal to what? 2. That's our answer for this question. Okay, which is option B. Or you can solve it in this way, that you know the value for log 16 to the base 2, that its value will be 4. You know this value also. Log 1 by 4 to the base 2, its value will be minus 2. Right? Log of 1 by 4 to the base 2, its value will be minus 2. So 4 minus 2. Yeah. So this is also you can solve it. So these are the property we have seen it till now. Now let me show you the next property, which is base changing theorem, which is again very, very important kind of property. Okay. Base changing theorem. This is the last property of logarithm. Okay. So there aren't much property. There are only few property, but you need to apply these properties very carefully. You don't do mistake in these property, and which will be solved with practice. Okay. So base changing theorem says that we can write log a to the base b. Log a to the base b can be written as log of a upon log of b. This is the statement of base changing theorem. Okay. This theorem says that log of a, currently the base is b, log of a to the base b, we can write this as log of a upon log of b, and we can choose any common base over here. We can choose any common base, whatever you want, you can choose any common base over here. Whether you can choose the base as 10, or you can choose the base as c, or you can choose the base as e, or 5, or 3, or 2, whatever you want to choose the base. As the name suggests, base changing theorem. Okay. So basically you can write this as log of a to the base 3 upon log of b to the base 3. Okay, log of a to the base b can be written as log of a to the base 3 upon log of b to the base 3, or you can write it as log of a to the base 5 upon log of b to the base 5, or you can write this as log of a to the base 7 upon whatever you want, or log of a to the base 10 upon log of b to the base 10. So this is what base changing theorem says. Okay, all of these things are equal, or vice versa. Vice versa means that if it is written, okay, this is the first property. Now understand the vice versa. Suppose if it is written that log of a upon log of b and their base is same, of course the base has to have the condition cleared up, that base should be not equal to 1 and base should be positive. So log of a upon log of b, if the base is same, whatever the base is, let's say base is 3 3, or let's say base is 5 5, or let's say the base is 10 10, whatever. Okay, so we can write this as log of a to the base b. That's the property. We can write this as log of a to the base b. So generally it is used to go from here to here. Like if log of a to the base 3 upon log of b to the base 3 is written, we can write it as log of a to the base b. Log of a to the base 5 upon log of b to the base 5 is written, we can write it as this thing. So whenever there are two logs in the division, and if we observe that base is same, there are two logs in the division, the base is same, so we can think of this property in these type of scenarios. Okay, so this is all about base changing theorem. Now base changing theorem gives us another important thing. It tells us that log of a to the base b is equal to 1 upon log of b to the base a. Yes, where the condition comes that a b should be positive and a b should not be equal to 1. See, because b is in the base, here a is in the base, so they should not be equal to 1, and of course they should be positive. Okay, now how do we prove this property? Very easy to prove this property. So we know that we can write log a to the base b as log of a upon log of b. We already know this. We can choose any common base over here, whatever we want. We can choose any common base. This is the base changing theorem. Okay, we are not going into the proof of base changing theorem. I did not tell you the proof of base changing theorem. I have directly told you what is the base changing theorem, because you don't need to know the proof. That's the thing. Okay, so log of a to the base b is log of a to the some base plus log of b to some base, right? Whatever we can choose this base. Suppose if I choose the base as a only, suppose choose the base as a only, what will happen? Okay, what will happen? You can write this as log of a to the base a upon log of b to the base a, right? I am choosing the common base as a only. Now what is log of a to the base a? Log of a to the base a will be 1. And in the denominator we have what? Log of b to the base a. Hence we can say that log a to the base b is equal to 1 upon log b to the base a. This is very important base changing theorem. For an example, we can write log 3 to the base 2 as 1 upon log 2 to the base 3. Basically interchange these two numbers, a, b, interchange these two numbers. Or 1 upon log 2 to the base 3 can be written as log 3 to the base 2. Clear? Let me show you an example on base changing theorem. So this question says that what is the value for the multiplication of log 4 to the base 3 multiplied by log 5 to the base 4 multiplied by log 6 to the base 5 multiplication and so on. It goes like this. So here I can use base changing property. See, I can write log 4 to the base 3 as log of 4 upon log of 3. Let's say the common base is 10. In the similar way, I can write log 5 to the base 4 as log of 5 upon log of 4. They are in the multiplication. Log 6 to the base 5, log of 6 upon log of 5. See, everything is in the multiplication. Then multiplied by log 7 to the base 6, which can be written as log 7 upon log 6. Log 8 to the base 7, which can be written as log of 8 upon log of 7. Log 9 to the base 8. Okay. Log 9 upon log 8. Okay, all of these things are in the multiplication. I have changed the base, everything, each of these logs base is what? 10. If I am not mentioning the base, you can consider the base as 10. Okay. So now you can see things getting cancelled out. Because they are in the multiplication, log 4 will get cancelled out. Here log 5 will get cancelled out. In the similar way, all of these things will get cancelled out. Now what do we have? We have log of 9 upon log of 3 remaining. So we are getting this is equal to log of 9 upon log of 3. This is what we have. Now log of 9 upon log of 3 can be again written as log of 9 to the base 3 because their base is same, right? Log of 9 upon log of 3 can be written as log of 9 to the base 3, which will be equal to what? Which will be equal to 2. That's our answer for this question, which is option B. Yes, easy. So this is what base changing theorem is. So in today's lecture, everyone, we have started logarithm, we have understood about logarithm, we have completed logarithm with all its properties. I have told you each and every properties. Of course, you need more practice on that, for which we are going to give you DPPs in which you can practice more on logarithm. Okay, or you can use any standard book, or you can use the modules to practice more about logarithm. So let me know how did you find this lecture. I have tried to keep this lecture short and crisp so that you get all the knowledge and I don't take much time of yours, because I know that you guys are already very occupied with your school classes, with your coaching classes and so on. Okay, so just manage your time properly so that you get time to practice, because that is very, very important. Okay, everyone, thank you everyone for being a part of this session. See you in the next one. Till then, take care. Tada, bye bye. Have a great day.